What are the methods of linear programming? Basically, we have two methods. One is graphical method and the other one is algebraic method. In linear programming, our objective is to find out how resources should be allocated to achieve the objective function, and that objective function can be either maximization or it can be minimization. Okay, so we can find out what should be the resources using either graphical method or algebraic method. Now, how to find through graphical method? In graphical method, we'll have objective function, then we'll also have constraint. We'll have objective function followed by constraints. Now, what is critical is, in graphical method we'll be drawing graphs and the constraints condition can be either less than or equal to, or it can be greater than or equal to. Say for example, there is a constraint when you have an objective function. Let's say your objective is maximizing profit when z is equal to, say, something like 4x1 plus 3x2. This is your objective function and you have a constraint. Let's say constraint number 1 is 2x1 plus 3x2 should be less than or equal to 10. So when you have constraint like this, how you can proceed further? You need, let's say you have one more constraint, or even one constraint is sufficient to identify the feasible region. So here, if I have a constraint like this, which is basically a linear inequality, why I am saying inequality? Because this is not equal, this is less than or equal. So I have to convert this first of all into equal by rewriting like this: 2x1 plus 3x2 equal to 10. Okay. Now, to identify the feasible region, to put it in a graph, I need points. I need straight line. Only then I'll be able to find out the feasible region. That is, I need some value for x, I need some value for x1 and x2. How I am going to do this? Now, let me assume if x1 is going to be 0, what will happen? 2 multiplied by 0 plus 3x2 is going to be 10. Okay. Now, for convenience sake, let me change this number 10 as 9. To put it, to have simplicity, let me change this number as 9. Okay. So what happens? I have 3x2 is equal to 9. It means I'll get x2 is equal to 9 by 3 and the value is going to be 3. Okay. So I'm getting a point now when x1 is 0, x2 is 3. Okay. Similarly, let me assume x2 as 0. Okay. If I assume x2 as 0, let's see what is going to happen. If x2 is equal to 0, then we'll have 2x1 plus 3 multiplied by 0 is equal to 9. That is, 2x1 will be 9. So we'll have x1 is equal to 9 by 2, which is going to be 4.50. Okay. So we got x1 as 4.50 and x2 as 0. It means now we have a point 4.50 comma 0. Okay. Now with these points, let me try to draw a graph and we'll see how it will look like. Now I am drawing a graph. Okay. So traditionally we'll call this vertical line as y-axis, horizontal as x-axis. Now I'm going to call this as x1, and in the place of y I'll call this as x2. Okay. And what are the points we had? Basically we had 2 points. One, when x1 is 0, x2 is 3, and when x1 is 4.5, x2 is 0. Okay. So let's plot that. Let me number them: 1, 2, 3, 4. We have x1 4.5, so let me extend this a bit. 5, so in between we have 4.5. This is x1, and in x2 we have 0, then we have, let's say, 1, 2, 3, and it goes. Okay. So the points we had What is the earlier point? Earlier point is 0 comma 3. That is when x1 is 0, x2 is 3. And when x1 is 4.5, x2 is 0. So now you can join these two lines. Okay. If you join these two lines, this is giving you a linear line, and that will exactly fit into this equation. That is 2x1 plus 3x2 is equal to 9. And if you test this, it is going to work. Why? Because what is the x1 here? What is the x1 in this line? In this line, x1 is 4.5 and x2 is 0. So apply that here. 2 into 4.5 plus 3 multiplied by 0, you get 9. Okay. Now let's try with the other value. What is the points here? It is 0 comma 3, right? That is x1 is 0 and x2 is 3. So apply that here. 2 multiplied by x1, which is 0, plus 3 multiplied by x2, which is 3, and it is equal to 9. So at this line, you have this equation exactly equal. Okay. But let's go back to the question or the case. The case says this should be less than or equal to 9. Okay. It means your focus area or your solution space, the space which complies with the constraint, means it should be less than or equal to 9. So any region which is less than or equal to 9. So let me shade this. Any region which is going to be less than or equal to 9 will ensure compliance with this constraint. And this constraint is 2x1 plus 3x2 should be less than or equal to 9. So this region will ensure that compliance. So this region will be called as, solution space. Let me write that in a different color. It will be called as solution space. Okay, now we have talked about only one constraint. So you can have various constraints. So whenever you have various constraints, you have to select space in such a way that the conditions of all constraints are complied with. Then that will be called as feasible region. Okay, so this is about graphical method. We'll be discussing in detail in subsequent problems. Then you have algebraic method. Okay, it is otherwise called as simplex method. As the name says, simple, it is actually a combination of simple and complex. I mean, it's not that theoretical definition, but I'm just giving because it has a very comprehensive approach for finding the feasible solution, or it has a very comprehensive approach for allocating resources. That is, there is a detailed algorithm process involved. Okay, so we'll understand what is simplex method in the subsequent sessions.